All right, so we're trying to get through a little tutorial on the graphing part that I know a lot of people are struggling with, and that's fine. This is very difficult stuff because you really have to take your time with it. So I hope this PowerPoint or this screencast helps graphing make a little bit easier. So this is where we started. We started with position time graphs, and we saw straight linear lines, and I hope everyone that recognizes this as a constant speed. So we look at the slope of the graph to tell us not only about what the object is doing, is it constant speed, speeding up, slowing down, but also about the direction. And the thing that gives us the key for this slope is understanding that the slope gives us both of those pieces of information. So you must know this, that the slope of a position time graph is going to equal the velocity. So not only the velocity, remember it's going to tell us not only the speed, which is the magnitude, but also the direction. And we're going to carry over this idea when we start looking at things that are accelerating. All right, so remembering that the slope of a position time graph is the slope. The greater the slope, the greater the velocity. Positive slope means positive velocity. And on the flip side, a negative slope, something that was going down in this direction, would tell us it was moving at a constant speed in the negative direction. All right, but what happens when we get to things that are speeding up? So this is the graph of an object speeding up. This was the car going down the ramp. What we want to look like at for the slope where it starts to change is we look at this tangent line. We take our curve and we look at what happens if we draw a tangent. And we talked a little bit about the tangent line when we talked about inertia and the circle puzzle. It touches the curve just at one single point. It never crosses into the line. And the slope of this tangent line, which we could do a rise over run on, represents the velocity at that moment in time. And we called that the instantaneous velocity. So moving on, we kind of understand that if we look at the slope and how it changes at several points, just pick a couple on the curve, to tell you what the speed is doing, increasing, decreasing, constant, and it's also going to tell you the direction. And my intent here with this screencast is to take you through a few examples and the step-by-step process. Please remember, it's a process. You have to take your time and think your way through it. It's not, the answer isn't just going to pop out at you. Take your time. All right, so back to this tangent line. This tangent line has what we call a positive slope. It's uphill. It tells us that the velocity is positive. If I were to take point slope method and do y2 minus y1 over x2 minus x1, I'm going to get a positive velocity. But in the physical world, what is actually going? The object is moving in the positive direction. All right, flip side, direction. This slope at this point has a negative slope. It means the object is going in the negative direction. So that should be the first question you ask yourself. And this is what I meant by the pencil test. It's like taking your pencil and laying it down on the curve and kind of figuring out what's going on at that moment in time, and then look at a couple of other points to kind of look at a change or a trend. All right, so on our velocity versus time graph, when we're trying to construct it, if we have a positive slope, it means I'm going to draw it in this first quadrant. And I talk about the first quadrant, kind of a math reference, and hopefully we're all familiar when I talk about the first quadrant. If the position time graph has a negative slope, it means a negative velocity, which means I'm going to draw the graph in this quadrant right here, the fourth quadrant. So that first question about whether the slope is positive or negative tells us where to draw the graph, either up here or I'm going to draw it up here. Okay, so that said, you just take yourself through that process and you say, okay, that's where I'm going to draw it. Now we have to figure out whether it's increasing or decreasing velocity, or perhaps even constant velocity, or maybe zero velocity. All right, so now we're going to look a little more specifically at this speeding up graph, and we're going to look at the slope at several points along the tangent line. So I go from A to B to C. And if I look at the slope of this line as it moves in time, it's showing me that it's increasing velocity. It's also showing me that it has a positive slope. So this positive slope means I'm going to draw it up here and I'm seeing increasing velocity. You see, even if I went down here and drew a tangent line here, it would be zero slope, which means telling me that the graph starts at zero speed and gets increasingly faster as it moves along. And that's how we draw the graph. And I know this is just kind of the basic graph and everybody's memorized it, but let's look at some other examples as we move along. All right. So we have the velocity time graph again. If we're looking at the magnitude, we want to show increasing speed. The greater the slope, the greater the velocity. So this is showing increasing speed, and we saw that in the last example. But if I was moving in the negative direction, this would also be increasing speed. Notice this negative sign does not means smaller than zero. The negative sign just means in what direction. So this is also a graph that's showing something that's speeding up, any graph that goes in that kind of a trend. So if we can kind of wrap our heads around that, then we can get through some possible examples. Now, when we go from the velocity to the acceleration graph, the same ideas are going to apply. Again, thing that you must know, that the slope of the velocity time graph is the acceleration. We are only doing constant acceleration, so the slope of the velocity versus time graph is either going to be positive and constant, negative or constant, or zero. These will always be just horizontal lines. It just depends where you're going to draw the horizontal line. All right, so let's go to the worksheet that we had from a couple of ones that I would consider maybe the little bit more challenging to wrap your heads around. This is number 7 on the stacks of graph. And this is the given position versus time graph, and we want to make the velocity time graph. So the first question you want to ask yourself is the slope positive or negative? So I know whether to draw it up here or down here. So we draw a tangent line. We lay down our pencil and do that pencil test. This is a negative slope. This is going to tell us that we need to draw the graph down here with negative values of velocity. The next question I need to ask myself is the velocity increasing, decreasing, or constant? Well, hopefully we can tell that this is not a constant slope. But if I look at another tangent line somewhere later in time, I see that it's getting less and less steep. This is telling me that the velocity is decreasing. And it's decreasing in the negative direction. So if it's decreasing, anything along this line right here means zero speed. So my decreasing velocity has to have this kind of trend. So the graph of that line would just look something like this. It starts at some high speed, high slope, and then ends up with sometime later with zero slope or zero speed. So we see this constant acceleration, deceleration, but we see a linear line that starts at some value and goes to zero. So again, the acceleration graph, I look at the slope of this line. This is a positive slope. It's uphill, which means I'm going to draw it up here in the first quadrant, and it's constant. So I'm going to see a constant positive value, constant value for the acceleration. So that's number 7 on the stacks. Let's do one more example. This is number 11 on the stack. So you remember this little line kind of delineated kind of a change in what's going on here. So we have two kinds of motion, something going on here, and then we have something else going on here. So we're going to take ourselves through the same process. So what do we see here? Positive slope. So that means I'm going to draw it up here. Okay. This looks like a pretty constant slope. So this is going to tell me that I'm going to have a constant velocity for that first unit of time, from this 0 unit to first unit in time. Okay, now let's look at the second one, this section right here. If we take that pencil test and we look at the slope as time goes on, we can see that it's getting less and less steep. It's still positive, but it's showing me that the object is slowing down. So I'm going to start where I finished, and I'm going to have an object that's showing slowing down to 0. So that's number 11 on the stacks, and that's pretty much taking you through position to velocity. So last bit is just going from the acceleration, and this one is almost simpler. Again, I'm looking at the same sections here. Here, 0 slope, so that's going to tell me 0 acceleration. Okay, this slope right here, is that positive or negative? Hope you said negative. So that's going to tell me a constant negative slope right here. And then we get to our acceleration graph. So good luck. I hope this helps a little bit.